In this function, we are asked to find the inverse function. So I'm going to find the inverse function and also do the check to make sure that they are inverses of each other. Okay. So the first step is to write y equals f of x. So y is equal to x over x plus 3. Then I'm going to solve this equation for x in terms of y. So what that means, I'm going to change this to y and change y to x. Change this to x. Okay, so x is equal to, I'll write the y in a different color, y over y plus 3. Now I need to solve for y. So I go x times y plus 3 is equal to y. So distribute the x, xy plus 3x is equal to y. Bring this y over to the left and move the 3x to the right. So xy minus y equals negative 3x. Now on the left hand side, factor out a y. X minus 1 equals negative 3x. Divide both sides by x minus 1. Y equals negative 3x over x minus 1. And this y is my f inverse of x. So this would be a negative 3x over x minus 1 following these 3 steps. Now how do I check for sure if this is my answer? Now if I take my composed of function and the inverse, or if I take inverse and the function, then both ways I must get x. If I do get x, then my answer is correct. If I don't, then I did something wrong in creating this inverse function. So let me first start with f composed with f inverse. Again, the meaning of this is f inverse of x. So again, the meaning means I'm taking the inverse function and putting it into the function. So the inverse function is negative 3x over x minus 1. I'm going to putting that in the function. So the numerator is going to be negative 3x over x minus 1 divided by negative 3x over x minus 1. Again, in order to do this problem, I'm going to write it horizontally to save some space. So negative 3x over x minus 1 divided by, that's what the meaning is, negative 3x over x minus 1 plus 3. So first one is a single fraction, so not to worry too much. For the second piece, the LCD is x minus 1. This is telling me I need an x minus 1 there and an x minus 1 in the bottom. So that's going to make it a negative 3x over x minus 1 divided by, this will be a negative 3x plus 3 times x minus 1 over x minus 1. Again, negative 3x over x minus 1 divided by, if I distribute the numerator, negative 3x plus 3x minus 3 over x minus 1. The 3x and the 3x cancels. I have a negative 3x over x minus 1 divided by negative 3 over x minus 1. Flip over and multiply. I'll have a negative 3x over of the second fraction times x minus 1 over negative 3. X minus 1 will cancel, negative 3 will cancel, ended up with the ax. Okay, now I need to do the same thing but backwards, right? So now I'm going to find f inverse of f. I'm using another color here. F inverse of the function f of x. So here the meaning is I'm taking the function f of x and putting it into f inverse of x. So let me go back and see my function f of x one more time. X over x plus 3. Negative 3 times whatever that value is, I'll use another color here, over minus 1. So this would be x over x plus 3, and this would be x over x plus 3. Okay, I'm going to do this, then I will zoom out to show you everything. Okay, so negative 3x over x plus 3 divided by x over x plus 3 minus 1. The first one is a single fraction, as I can write that as negative 3x over x plus 3. But the second one, I need to find what the LCD is. X plus 3. So that tells me I need an x plus 3 to this one, to the top and to the bottom. So the numerator is x minus parentheses x plus 3 over x plus 3. So be very careful when you see a negative sign like that, because this negative is one of the common mistake that happens. Is people ignore this negative sign to the second term when they distribute. Divided by x minus 3. It's not plus 3, minus 3 over x plus 3. So x's gets cancelled. I get a negative 3x over x plus 3 divided by negative 3 over x plus 3. Flip over and multiply the second fraction times x plus 3 over negative 3. X plus 3 is cancelled, negative 3 cancel, and I'm ending up to be an x. So since both ways I'm getting x, the conclusion is, see, both ways I'm getting x. Here I'm getting an x, and here I'm getting an x. And therefore it's satisfying the condition that when I take the function and the composition on both sides, therefore whatever I got for my answer for inverse function is correct. So this is an inverse function.